This presentation is entitled Requirements, Bloody Requirements. It's a bit of a play on words from a classic John Cleese training video called Meetings, Bloody Meetings that we'll get to see in CS461. The other thing I have in my notes is from Jagger and Richards, the preeminent authors on software engineering, who said you can't always get what you want, but if you try sometimes, you just might find you get what you need. And, I've always wanted to cite those two because they're complete luminaries in the field. And so I've done it. We've gotten John Goblikon and the Rolling Stones in here. So I feel as though there's not much left to learn, but let's go through and talk a little bit about requirements. Today we'll look at software requirements, functional and non-functional, and then user requirements versus system requirements. And we'll talk a little bit about user stories. User stories are short, simple descriptions of a feature told from the perspective of a person who desires the new capability. That's usually a user or a customer of the system. And this definition for user stories is from Mountain Goat Software. While we'll be maintaining a set of stories for our Agile system this year, it's good to know about traditional requirements. In fact, user stories often encompass several different requirements that you can see when you break it down into the atomic tasks. So what is requirements engineering? And here I have a couple of very weighty definitions. So Catonia and Somerville's a co-author, said requirements engineering is the systemic process of eliciting, understanding, analyzing, and documenting the constraints on the system and the background information necessary to develop the system. The Software Engineering Institute says it involves all lifecycle activities devoted to the identification of user requirements, analysis of the requirements to derive additional requirements, documentation of the requirements as a specification, and validation of the documented requirements against user needs, as well as processes that support these activities. So these are pretty long-winded. I prefer Catonia and Somerville, but the SEI definition is a bit more general than what Catonia and Somerville have. So let's take a look at types of requirements. So two of them are generally user requirements, which are statements in natural languages plus diagrams of the services the system provides and its operational constraint. These are written for customers or product owners. System requirements are a structured document setting out detailed description of the system's functions, services, and operational constraints. They define what should be implemented, so they may be part of a contract between the client and the contractor. And, I may be getting a bit old, but we used to divide these into two separate documents. One was the requirement document, which corresponds to user requirements, and the other was the functional specification. We then had a complete design of the system. Anyway, we typically divide the requirements into two types from here, functional and non-functional. However, there are also design process and domain requirements that we'll see. So let's take a look at functional requirements. These are statements of services. These are things the system should provide, how the system should react to particular inputs, and how the system should behave in particular situations. So basically, functional requirements say what the system should do. For example, the system shall provide appropriate viewers for the user to read the document in the document store. Functional requirements should be consistent and complete, and sometimes this is hard to do in large systems. Completeness means that all services required by the user should be defined. Consistency means the requirement should not have contradictory definitions, although sometimes, as I pointed out, inconsistency is unavoidable in large systems. For example, there may be different date requirements for the backend database versus the front-end UI, depending on where the backend database is from and for whom the front-end UI is being done, because dates are expressed differently in different parts of the world. So the example here, the system shall provide appropriate viewers for the user to read the document in the document store. It is a bit vague and probably more at a user level than the system requirement level. And, again, that's accepting Somerville's definitions. So let's take a look at non-functional requirements. These are constraints on the services or functions offered by the system, such as timing constraints. They can also be on the development processes or standards. They're not directly concerned with the specific functions delivered by the system, but they're more focused on those emergent properties of the system. So what are some non-functional requirements? Somerville has a figure in the 10th edition of the text, and I think it's on page 94, that gives a good partitioning of non-functional requirements, but they generally fall into three types. One are product requirements, such as performance or memory. Examples include performance, memory, and reliability requirements. Organizational requirements are derived from the policies and procedures of the organization. They can be from either the developer or the customer's organization, but often from the customer's organization. And then external requirements is a very broad heading. These are generally legislative, government, and ethical requirements. As an example, the U.S. government required that there could be no hidden functionality in products that they purchased, and we'll see how that impacted Microsoft a bit later on in the lecture. There are also domain requirements. These are requirements that come from the application domain of the system and reflect characteristics of that domain. These typically take the form of specialized knowledge and conformance to the industry standards for which the product is being developed, and also have very specific terminology. So one of the cool things, or not so cool things, depending on your perspective of life and software engineering, is that you get to learn a lot about a whole wide scope of different bodies of knowledge. I've worked in medical informatics. I've worked with the auto industry. I've done structural engineering projects with software engineering. So, I've had a good variety of experiences and exposure to domains that I probably ordinarily wouldn't have looked at. So, domain requirements section of the book has been moved to one of Somerville's web chapters, and you can read it if you're interested. But just as an example, here we have one that's the deceleration of the train shall be computed as the deceleration of the train is equal to the deceleration of the control plus the deceleration of the gradient, where the deceleration of the gradient is 9.1 meters per second squared times the compensated gradient alpha, and the value is 9.1 meters per second squared divided by alpha are known for different types of trains. That's pretty weighty. So, if you were developing that train system, you would actually have to go in and learn a bit about how trains decelerate and accelerate. So, getting back to hidden requirements, and this is another type. These are sometimes known as Easter eggs. And as I mentioned, the U.S. government began requiring that there be no hidden functionality in software they purchased, and this ended Microsoft's Easter eggs. The picture here is Dev Hunter from Excel 2000. You can see how dropping oil slicks in your Excel spreadsheet might cause great national security concerns. But they're so common in video games, but they're no longer in Windows productivity software used by the military. Which is a shame, because I think one of them had a complete flight simulator inside of it. So the different types of requirements are functional requirements, specify some services or functionality to be provided by the system. Non-functional define operational constraints on the behavior of the system. Design requirements define constraints on system design and implementation. For example, we're using Agile would be a type of process requirement. Design would say, hey, we have to design it to have the look and feel of the UHELO website as specified by the UHELO look and feel requirements. Domain requirements that come from the application domain of the system and reflect the characteristics of that, like our train system. So let's take a look at user requirements, and I've got a little quote from Noam Chomsky, and yeah, they're about that detailed. What Chomsky was trying to say here is that semantics are more important than syntax. This is a correctly formed sentence from a syntax point of view, but semantically it's pretty void in terms of its meaning. So, this was a point that Chomsky was making. We'll get back to Chomsky in a few minutes. User requirements in natural language. They should be understandable by users. They should avoid system design characteristics. Try to write them in a simple language, because again, they're for users. And language, though, can create problems. Lack of clarity, ambiguity, confusion as to what the requirements mean, or requirements amalgamation, and the little Latin there means from many one. And so, you can get many different requirements being put inside a single requirement. And so, Chomsky says language is a process of free creation. Its laws and principles are fixed, but the manner in which principles of generation are used is free and infinitely varied. Even the interpretation and use of words involves a process of free creation. And in fewer words, he summarizes the points from the chapter about natural language. Natural language understanding relies on specification, readers and writers using the same words for the same concept. That doesn't always happen. Natural language requirements are sometimes overly flexible, and there's no easy way to modularize natural language requirements. For these reasons, you often want to go with a formal notation, and Somerville gives 4 types of formal notation in figures 410 and 411 on the pages 106, 107 of the 10th edition. If you have the old 8th edition, they're on page 131. I encourage you to use structured natural language and graphical notations if you're writing requirements, or sometimes these just help you to flesh out your user story, so they are valuable. Natural language mix-ups are pretty famous. This is an example called Who's on First from Lou Abbott and Costello. And for those of you who are keeping score at home, who is first base? What is second? Third base is I don't know. Left field is why. Center field is because. The pitcher is tomorrow. The catcher is today. The shortstop is I don't care. And the right fielder is oddly enough not given a name in this routine. So what are the alternatives to natural language specification? Some of them are structured natural language, design description languages, graphical notations, and mathematical specifications. We'll generally use a combination of structured natural language and graphical notations because those are the easiest to get at. Design description languages are pretty uncommon, and formal specification, it's great for something that's a safety critical system, something like the monorail over on Oahu. But in general, it doesn't scale well for these types of projects in our software engineering class. We will take a look at mathematical specifications in CS461 because they are often used in safety critical systems. In terms of a graphical notation, this is an example of a sequence diagram of an ATM withdrawal. And this is one in UML, Unified Modeling Language. And we'll see more about sequence diagrams in UML later. But this is one way of showing how the state changes for a particular program and the types of messages that are being passed to the different types of objects and what their responses should be, as well as the timeline which proceeds from up to down. So in agile methods, we typically maintain something known as a product backlog, which is a list of all the things that need to be done within the project. It generally replaces that traditional requirements document and the specification document. However, I'd still like to spend a bit of time on this topic because you may be working on a traditional project when you graduate, or you may need to reference one of these documents for system maintenance purposes, particularly if you're working with the brownfield project. Let's take a look at Dilbert's views on the subject. So here we have one of us will have to read this gigantic product requirements document, unless it gets destroyed in a freak accident. And the intern says it's like watching Thomas Edison work. And Wally says, I have some oily rags in my cube. So, that's one way to go about it. The huge requirements document was destroyed in a freak accident. I'll ask marketing to send you a new copy. I told you we can't stop them one bee at a time. We have to go for the queen. So, the requirements document is always there. And they do tend to be very, very weighty. So, in traditional development, it's the main artifact from the requirement determination phase. The main portion of the requirement documents consists of 2 types of statements, services and constraints. And services are what it should provide, and constraints deal with how it should provide those. It should also address project issues, beginning and end of document, and how those were resolved. So, writing requirements are generally written in natural language. Avoid using complex conditional clauses. For example, if A, then B, else if C, then D, else E or F. And same thing, don't be David Foster Wallace when you're writing these. Use active voice to write your requirements, not passive voice. So that means subject, verb, object, so that you know who or what performed the action, not object, verb, where you have to guess. Make them easy to understand, that is, use as simple language as possible. Define acronym and specific domain terms, as often as necessary. And specify requirements quantitatively so that they can be measured. Somerville actually has a one sentence per requirement policy, and I think that's a pretty good idea when you can actually accomplish it, although sometimes they need more elaboration. So where do you get a requirements document? Well, requirement document templates are pretty widely available. Textbooks have them, standards organizations, ACM, IEEE, consulting firms will have their own. Case tools can often build them for you. If you just Google, you'll be able to find it. And in practice, each organization develops its own requirements document. So here's the requirement document, which is the IEEE standard. And this version is used in Somerville. Somerville does add an extra area to track system evolution, as it's not in the original IEEE template. But you have a preface, an introduction, glossary, general user requirements, system architecture, hardware specification, detailed software specification, reliability and performance requirements, and last but not least, an index. So as always, thank you so much for watching, and no need to like, share, or subscribe here. And you don't have to turn on notifications either. Thanks again.